Now when we have understood the representation and definition of vectors, now next we shift to algebra of vectors. The first thing I'll take here, addition of vectors. Addition of vectors. How and what exactly you mean by addition of vectors? The first is triangle law of vector addition. Triangle law of vector addition. What is very special about vector addition, before I state you should know, like in ordinary algebra, in ordinary say arithmetic, 2 plus 3 is 5. In vector, it is not always necessary that a force of 2 Newton is applied on a body and the force of 3 Newton is applied on the same body but may not be in the same direction. Then their total effect, that is their vector sum, is not necessarily 5. In a very particular case it could be 5. So all this is to be discussed. What is the combined effect of two vector quantities when they are added? Or in a simple words, if two or more forces are applied at a particular point, will the magnitude of their vector sum will be the same as the sum of their separate magnitudes, or will it be different? So now first of all I discuss here the triangle law of vector addition. What is triangle law? That if two vectors, look here, say two vectors, vector A and vector B, are denoted by two sides of a triangle, say AB and BC, like this, taken in order. If two vectors A and B are denoted by two sides of a triangle in magnitude, that is magnitude of AB, magnitude of vector A is same as the length AB and magnitude of vector B is denoted by length BC, then their vector sum is denoted by the third side in magnitude and direction, remember, taken in opposite order. So here I say that vector AB plus vector BC, denoted, as I said, denoted by magnitude and direction. Do you notice here that the terminal point of vector A is the initial point of vector B when we are applying the triangle of vector addition, and their vector sum is AC. Here you find that the direction of A, B and BC are taken in order in one cycle, but that of AC is in the opposite cycle, taken in opposite order. So AB plus BC is equal to AC, or in short I may write here vector A plus vector B equal to vector C as being denoted in the diagram. Now, here we should make another note. What if three vectors A, B, C, vector A, vector B, vector C, are denoted by the three sides of a triangle ABC as AB, BC and CA, that is taken in order? Then you will find that their vector sum is 0. A plus B plus C is 0. How do you justify this? You know, just now as we defined, take the proof of this. I repeat the statement that if three vectors A, B, C are represented by the sides of a triangle in magnitude and direction taken in order in the same cycle, then their vector sum is 0. So this is the diagram, this is the result, that A plus B. How do you justify? See here, using the triangle law, AB plus BC will be equal to AC. So you take AC on the left, you get AB plus BC equal to negative AC. Sorry, AB plus BC, take AC on the left, minus AC equal to 0. Now remember here that vector CA, if you change the order of terminal and initial point, it may be written as minus AC. So minus AC here may be replaced by plus CA. So AB plus BC plus CA is 0, or vector A plus vector B plus vector C is 0. Now the next property is, how do you find a vector along a particular segment if we know the position vectors? The vector AB, what is vector AB? If the position vector of the point A is A and the position vector of point B is B. See here. Let A and B are 2 points whose position vectors are A and B, of course have to be with reference to some point O. If the position vector of a point A is A, that means vector OA is A, and if the position vector of point B is B, that means vector OB is vector B. And now, what will be vector AB in terms of small a and b vectors? That's what we are wondering. How much will be vector AB? So look at it using the triangle of vector A, okay, OA plus AB. Along we are discussing in triangle OAB. OA plus AB will be equal to OB. That is, if I write in short, vector A plus vector AB equal to vector B, or vector AB equal to vector B minus A. How do you take it? That if, I repeat, that if AB is a segment like this and its points A and B, the position vectors of the point A and B are vector A and vector B, then vector AB is B minus A. That is, it is always terminal minus initial. Look at it from here. If you want to find out vector AB, you know the position vector point A and B, then how much will be AB? AB, what is the terminal point B? What is the initial point A? So it is in the opposite order, that is B minus A. Let me take more examples. Suppose you have few points A, B, C, D, and their position vectors are respectively denoted by A, B, C, D, small symbols, A, B, C, D. Can you tell me how much will be vector CA? Vector CA, say this vector. It will be A minus C. When you are making vector CA, the terminal point is A, so it is A minus C. What will be vector DC? Vector DC. What is the terminal point here? C. What is the initial point? D. So it will be C minus D. So that's what I want to teach you, that if you know the position vectors of certain points, can we work out the vectors along the segment joining the two. Now the next is parallelogram law of vector addition. Parallelogram law of vector addition. What is parallelogram law of vector addition? That if two vectors, say vector A and B, are denoted by two sides of a parallelogram with the same initial point, say O. Here let me call OA and OB are the two sides of a parallelogram OACB. So if vector A and vector B are denoted by two adjacent sides of a parallelogram with common initial point, then what is their vector sum? Then the diagonal through this same initial point, that is C, then OC denotes their vector sum. That is vector OA plus OB equal to vector OC. And if I denote vector OC by symbol C, small c, we can say vector A plus vector B equal to vector